Welcome back to my channel. Everything looks set, endpoint ready, API key generated, but your AI still won't reply. The reason you haven't deployed a model yet. In the previous video, we created our Azure OpenAI resource and received the endpoint and API key. Your application will use this endpoint and key whenever it needs to communicate with Azure OpenAI. But right now, the resource is just an empty container. There is no AI model running inside it. So, even if your app sends a request, Azure doesn't know which model should respond, GPT-4, GPT 4.1, or anything else. To fix this, we need model deployment. Model deployment means selecting a model and making it available inside our resource. Once deployed, it gets a deployment name, and our application will use that name to talk to the model. In this video, let's deploy our first AI model so our application can finally start communicating with it. Before we move ahead, remember this: Azure Portal is where you create and manage your resources, like setting up Azure OpenAI, generating keys, and handling configurations. But Azure Foundry is where the real AI work happens. That's where you test models, deploy them, experiment in the playground, and build your AI applications using those resources. Now, to deploy a model, go to the Playground section inside your Azure OpenAI resource. In the Playground, you will see all the model deployments that belong to this resource. But since we have just created this resource and haven't deployed any model yet, this section is currently empty. To deploy a model, click on Create New Deployment. Once you click that, Azure gives you two options. First, base model. This is a ready to use model provided by Azure like GPT-4, GPT 4.1. Most beginners and many real applications use this model because they are already trained. Second option is fine tuned model. This is used when you want to customize a model using your own data. Since we are just getting started, we will select base model and deploy it. Now we can see the list of available models. From here, we can select which model we want to deploy in our resource. For this demo, we will select the GPT 4.1 Nano base model for deployment. On this screen, we can also see all the model details. If everything looks good, we will click on deploy. After clicking deploy, a deployment form will open. In this form, we need to provide some deployment details. Here, we will enter things like deployment name. Deployment name is the name our application will use to call the model. If you want, you can also change the deployment name. Here, we are naming our model deployment as GPT 4.1 Tech Talks. Next, we have deployment type. It simply means how your AI model will run and handle traffic. In other words, how much usage it can support and how it scales. Here, I have mentioned the usage requirement for each type, so you can choose the deployment type based on your project needs. Now, in the deployment form, you will see something called model version. Model version simply means the specific release of the AI model. For example, if we are using GPT 4.1 Nano version 2025-0414, this means this model was released on April 14, 2025. Just like mobile apps get updates and new versions, AI models also get improvements over time, like better performance, bug fixes, and more accurate responses. But here is the important part. When we deploy a model in Azure, Azure locks our deployment to that exact version. This ensures our application gives consistent results and doesn't suddenly change its behavior if a new model version is released. For example, Suppose GPT 4.1 Nano gets a new version tomorrow. Even then, our application will continue using version 2025-0414. It will only change when we manually upgrade the version in the deployment settings. So, the model version helps us maintain stability, consistency, and control over when we want to update our AI model. Next, we have authentication type. It means how your application will securely connect to the deployed model. Key is the common authentication type. Your app sends a secret key with every request. If key is valid, model responds. Before we understand tokens per minute limit, first let's understand what a token is. In Azure OpenAI or Azure Foundry, a token is a small unit of text that the AI model reads and writes. You can think of tokens as pieces of words. For example, the word hello is one token. The sentence hello, how are you is around 5 to 6 tokens. Long paragraphs contain hundreds of tokens. Why tokens matter in Azure AI Foundry? Tokens are very important because they control cost, limits, and performance of your AI model. First, let's discuss cost. In Azure Foundry, billing is based on the number of tokens used. Every time your application sends a request to the model, Azure counts input token, the text you send in the prompt, output tokens, the response generated by the AI model. Both together decide how much you are charged. So, longer prompts and longer responses mean more tokens and higher cost. Next, we have limits. Every AI model has a token limit. This means there is a maximum amount of text the model can process at one time. For example, if a model has a large token limit, it can handle long conversations or big documents. If the limit is smaller, you must send shorter prompts. There are also limits like tokens per minute. Tokens per minute is the maximum number of tokens an AI model can process in 1 minute. It includes both input and output tokens. This limit is called capacity and it determines how much traffic your AI app can handle. Next, we have resource location. It is the Azure region where your service and model are physically hosted and executed. Then we have content safety. It ensures that the deployed AI model follows responsible AI rules and doesn't generate harmful or unsafe content. It acts as a built in filter that protects users and applications. By default, these are pre selected, but if needed, you can customize these settings based on your requirement. You can change the model version from here. Right now, only one version is available for this model, so that is selected automatically. You can also adjust the token or capacity limits from here. Once we fill in these details and click deploy, the model will be deployed inside our Azure OpenAI resource. After deployment is completed, this model will appear in the playground and now our application can start communicating with the AI model using the endpoint key and deployment name.